Hi, welcome to Exponential Functions Integration. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This calculus lecture comes to us from Chapter 5 of Larson's 11th edition calculus text. 5.4 Exponential Functions, Differentiation and Integration. Part 1, I did the differentiation. Now in Part 2, we're going to do the integration. So, first of all, integration rules for natural exponential functions. These are only base e, right? Just the natural exponential functions, not all exponential functions in general. We'll get there later. Now, in part 1, we learned that the derivative of e to the x is itself e to the x. So, keeping that in mind, the antiderivative of e to the x dx is itself e to the x plus c. Now, the integral of e to the u du is e to the u plus c. It's that easy. Don't overthink it. Don't make it harder than it needs to be. Just let it be straightforward. So, if we're finding the indefinite integral, integral of e to the negative x to the fourth times minus 4x cubed dx, we'll do a simple substitution. We'll let u be our exponent, negative x to the fourth. Then du is minus 4x cubed. So this entire part is taken up by du, and I have e to the u. So rewriting our integral, e to the negative x to the fourth times minus 4x cubed dx as the integral of e to the u du just gives us an answer of e to the u plus c. And this antiderivative, when we replace u, becomes e to the minus x to the fourth plus c. That's it. Do a simple substitution, make it easy, take the easy, reverse our substitution. Here we have the integral of e to the x times the quantity e to the x plus 1 all squared dx. So I'm going to let u be the inside, right? When we first talked about u substitutions, we made u the inside of a square, the inside of a radical, the inside of a trig function, the inside of a denominator. We did various things, so u equals e to the x plus 1 makes sense. The derivative of e to the x plus 1 is e to the x dx. That takes care of our e to the x, our dx. This becomes u squared. The integral of u squared du is u cubed over 3 plus c. And reverse our substitution to get the quantity e to the x plus 1, all cubed over 3 plus c. Just because you see an e to the x inside as the integrand doesn't necessarily mean we're going to have an e to the u integral, right? Our substitution could make that irrelevant until the very end after we reverse our substitution. For the integral of e to the 2x plus 2e to the x plus 1 all over e to the x, the first thing I'm going to do is simplify the integrand. So e to the 2x over e to the x is e to the x. 2e to the x over e to the x is 2. And 1 over e to the x is e to the negative x. Now, I will integrate. The antiderivative of e to the x is e to the x. The antiderivative of 2 is 2x. If we let u be a negative x, then du is a minus dx. So the integral of e to the negative x will be minus e to the negative x. Don't forget the constant of integration that we add at the end. Always a capital C if you're using WebAssign. And pay attention, is there a C outside of the answer box or not? If you're doing indefinite integration, you must make sure that there is a capital C or constant of integration. For definite integrals, same process. We'll do substitution twice. In definite integrals, we do both of those substitutions up front. With indefinite integrals, we start it with a substitution and end with a substitution. So the integral from 3 to 4 of e to the 3 minus x dx, I'm going to let u be the exponent, 3 minus x. Then du is minus dx. Also, when x is 3, u is 0. And when x is 4, u will be negative 1. 3 minus 4 is negative 1. So I take my integral in terms of x, and I rewrite it in terms of u, the negative integral from 0 to negative 1 of e to the u du. And we know that this is negative e to the u evaluated from 0 to negative 1. Yes, the order must be backwards as we would think. But we can still do this. A minus e to the u evaluated at -1, and then subtract. A minus e to the 0. E to the 0 is 1. Subtracting a negative, I'll add 1. And a negative e to the -1 is a -1 over e. This is a fantastic answer. This is an exact answer. This is a great answer for you to write down. You shouldn't need a calculator to do many of these problems. If we're looking at the integral from 0 to 1 of e to the x over 5 minus e to the x dx, when u equals 5 minus e to the x, then the derivative is it's 0 minus e to the x dx, so a negative e to the x dx. I don't have a negative up here, so we'll compensate with 1 outside of the integral. Substitute the second time when x is 0. E to the 0 is 1. 5 minus 1 is 4. When x equals 1, 5 minus e to the first, that's 5 minus e, is our upper limit. So now the integral from 0 to 1 of e to the x over 5 minus e to the x dx equals the integral from 4 to 5 minus e of 1 over u du. We know the integral of 1 over u. That's the natural log of the absolute value of u. And we have our negative sign here. Don't forget to carry it along. Don't forget the absolute values. Actually, in this case, they're both positive, so it doesn't really matter, but I'll evaluate a negative natural log of absolute value of 5 minus e minus a negative natural log of 4. If you want to, right, we could change the order of subtraction. 2 negatives make a positive. Natural log of 4 minus natural log of 5 minus e. And if you wanted to rewrite those into a single log, not as a common log, that's something different. Using the quotient rule, quotient property of logarithms, we could write that as natural log of 4 over 5 minus e. No longer needing the absolute values because they're both positive. That's it for the natural exponential function with integration. Thanks for listening.